All right, guys, we are now recording. Okay, the sign-in sheet is going around. Please sign in. Okay, so today is lab day, Wednesday, week 1. So let's go ahead to ITS 365. Right. So I'll give some time today for everyone to get set up, kind of give you an idea. But today you're going to be coding, right? Should be pretty easy. This is meant to be more of a developing muscle memory, right? Coding. That's kind of what I call it. So I really just want you to go through like 80 examples. All right. You're going to have a Monday off, so you can use, Monday to work on it. Okay. So it's just going to be some practice. I'll give you the reasons why I think this is really important. And I highly recommend that you do it. And if you didn't understand, going through all the problems, then do them again and again and again until in your head, at least you've memorized it. What you're learning is how to do multiplications and adding and subtracting again, but in a different way and in a way that is very helpful in machine learning. Does that make sense? All right, so we'll talk about that. The reasons why this is important. It's actually one of the most crucial things, in my opinion. You don't have to master it now, but just keep doing it, and eventually you'll start to feel more comfortable with it. And that's really all I'm asking. All right, so on the agenda today, so basically I went over the syllabus on Monday. Today I want to go back to the environment, Anaconda. We're going to use Jupyter notebooks, and we're just going to go through some problems. And I'll go through some of them myself, kind of, tell you what I want you to do with them, but I can't cover all of them. So some of them you just do on your own. And I'll show you where the link for that is so you can take a look. Next week, we'll probably do word problems on Wednesday. And that's going to be the thing where I give you a scenario, build a machine learning classifier for network security. How would that work? Right? So we're going to think about that process of going from a word problem to formatting it and the data and thinking about what we would need, what are the inputs to a machine learning model, right? So those don't require any coding, but we'll do a few of those problems, and that'll probably be your first homework assignment, okay? So this one with the problems is not a homework assignment. If you don't do it, I won't know, but I recommend that you do it. It's for your own good. Otherwise, later in the semester, you're gonna regret not having done that. All right? Yeah, go ahead. You can do a what? Yeah, exactly. You don't have to submit anything. In fact, just create a whole bunch of Jupyter notebooks and just run it. So the whole point is I'm giving you some code and I want you to just type it and run it and see, oh, and like, okay, I understand what happened here. And then do another one and another one. You're just learning by doing. Okay. And just keep in mind, those are going to be some math operations, but math operations that are important for machine learning. Okay. And I'll talk a little bit about them, of course, but that's basically it. So there's no homework assignment. I won't know if you did it, but I highly recommend that you do these problems. Okay. It'll help you out a lot. And then next week, we'll probably do word problems, and then I will give you a set of 3 to 5 problems that you have to solve. All right, and that's going to be very easy, no coding. And that's the only assignment that won't have really like coding and things like that. And then after that, the next thing we will cover is something called Weka. And that's a nice GUI-based tool set for machine learning. So I like to start with that because Weka allows you to very easily take data, run it through several machine learning algorithms, and then measure performance. So the nice thing about that is it shows you the entire pipeline of machine learning from data to results without having to worry about like the code inside, right? So we treat basically the code as just black boxes. And I just want to see the process from beginning to end, and that'll allow you to understand the process really well. And then after that, we will start with the algorithms, which will involve coding. Does that make sense, guys? Yeah, so that's kind of the plan going forward. So today then, we're going to start with Anaconda again, and we're going to do some linear algebra problems, or what I call, actually, I don't call them linear algebra, I call them tensor operations. And so because linear algebra is a math class, right? If you want to take one math class from the math department and you like machine learning, that's the class I would recommend. Now, you don't need everything in linear algebra for machine learning. There's a lot of topics that have nothing to do with it, really, but there's a subset in there that is crucial to machine learning. So if you've ever wanted to take one math class for fun and you like machine learning, that's the class I would recommend. That really the class that's going to pay off, right? If you take calculus, other things, you don't do calculus in machine learning. The algorithms are doing calculus, but you don't do it. But with linear algebra, as you will see with these examples, you do kind of have to understand, because this is how you process data efficiently. And I'll talk about that as well. Okay. All right. So any questions before I get started? All right. So I think your homework assignment for today, which you don't have to submit either, was to set up your Anaconda environment, right? Did everyone do that? Are you all good with Anaconda? Do you guys have a question? You were not here? Okay. And you also are having an issue? Yeah. So what you have to do is it's very easy if you're using Windows, for instance. Oh, yeah, go ahead. Okay. All right. So yeah. So I'll start again with Anaconda. Okay. So you have to go to, these are the resources. So there's no, so you have to just go online, go to anaconda.org. Anaconda. It's the operating system for AI. The name used to be the toolkit for data science. Now the buzzword is AI. So now it's called, the tagline is the operating system for AI. Anyway, so there should be something in here that says where? Yeah. Where is it? Oh, there we go. Okay, yeah, thank you. So yeah, so you have to go in here, skip registration, and all you have to do is download for your operating system, or whatever it is. I have my Mac, and I actually code on my Mac, but I also have it here. So you would pick basically Windows, download it, double click, go through the whole GUI. Does that make sense? Once you've done that, so that's it. That's all you have to do. So do that, install the program. Once it's installed, and am I recording this? Am I starting? I am, right? Yeah, so we're recording. All right, so just follow the video. Oh, also, you can check out the video from Monday if you missed it. That should be on the YouTube channel. Okay. So we should be recording. So after you've done the installation, you can go to Start in Windows, go to All, go to Anaconda. And I like to use Anaconda prompt. There are other ways of starting this, but I just, I have my habits. So then once you're at the terminal, you should have this, right? That says base. And I'll repeat this again. That's the environment. Okay. So Anaconda is an environment management system, like a dependencies management system. So whenever you're doing machine learning, you're installing a lot of libraries, right? And sometimes you have to use Python 7. I'm doing something right now with something called AI agents. I have to use Python 3.10. But for this class, we're using Python 3.7, you see. So you can use multiple versions, and that's what Anaconda is really good for. So in this case, I have base here, but I'm going to do conda environment list. and it loads all the environments. So on Monday, and on Monday's video, I showed how to create an environment. So you can just reference that. I've already created the environment here, Python 3.7. I called it 2025 ITS 365. So this is the environment I'm going to use today. So then all I have to do is conda activate Py37 2025 ITS 365. So you hit enter, and there it is. If you notice, the environment has now changed from base to that, and that's what you want. So now you can go in here and just install all the programs that you want. One really nice thing is that really all you need is pip for everything, and that makes your life so much easier, okay? You can install programs here in the command line, or you can install them in the Jupyter Notebook itself. I like to do that there because then I can record what dependencies I actually needed for the program. And so that's my preferred method. Got it? All right, so hopefully everyone is here, right? And so we're going to go ahead, and I basically just installed Torch, I believe, the last time around. And I also installed, obviously, Jupyter Notebook. That's going to be my preferred IDE for this class. All right, so I'm going to do then, to start Jupyter, I just have to type Jupyter Notebook, just like that. Hit enter. Give it a minute, and it should basically open up a website. I'm gonna close. All right, and yeah. So I guess I was not in the right folder. That was my mistake. I can correct that. So let me go kill it. So CLS. All right. So one thing I didn't do is I didn't navigate to the desktop, to my folder. So I want to keep my files in a centralized location so I don't lose them, right? And I usually just use the desktop. So that's what I'm going to do. I'm going to navigate to desktop here, CLS, dir. And I think we also created our folder for this semester on Monday. So you can check out the video from Monday, ITS 365 2025 Spring. So I'm going to go ahead and navigate into that one. CD ITS 360. Okay. 2025 Spring. All right, so I should be there now. And I guess, did we do something? I guess we started with something. So we do have a Jupyter Notebook in there. So I'm going to go ahead now and basically start Jupyter. I'm going to do Jupyter Notebook. There we go. Okay, here we are. So I started, I guess, this Jupyter Notebook on Monday just to kind of illustrate how it works. So now, if I want to create a new file, I can just go to New and select Python 3, and it's going to create a new entry here. And then I just change the name. But since I already have this one, what I'm going to do instead is I'm just going to start that one. So you can just click on it, and you can see it opens like a new window, a new tab on the browser. And there we go. So this is what we did on Monday, basically just showing some of the libraries. So Torch was already installed, and then Numpy was not installed, so I had to install it. And this is the way that we can do that from Jupyter, just by adding an exclamation and pip. And of course, we remove the comments, right? So there's a couple. So right now, what I'm going to do is I'm going to show you the interface of Jupyter, right? So we're going to go over the menu and just try to learn what these things do, basically, which might be helpful. So as you can see, these are cells. So basically, this is for saving. Now, I usually like to change the name, so I just do something like rename. You can see that. So you could, for instance, do 2 or whatever you want, and you would rename it. So I'm going to keep it as is. All right. So these are the commands I usually use. If I want to run a cell, I hit run. If I want to add a cell, let's say a cell between these two, I would hit the plus sign here. And you can see I can add a little cell in there. As you're coding, you might say, okay, I needed a function here, so I'm going to add it. All right. Other things that you will see me do a lot is I like to refresh everything sometimes. Like I've been running the code, there's data in the variables, and I want to clear everything out and just go back to a fresh start. So what I can do is so for instance, let me do an example. I'll do print hello, right? And I'm going to run that. You can see there's output on the Jupyter, variables are initialized, etc. But I want to refresh it, restart it, so I can go to the kernel and I can hit restart and clear output. And then I'm just going to press this button again. It's thinking there. And now you can see the hello went away and you kind of like refresh the Jupyter and you're ready to reuse it. So you'll see me do this a lot. Like having some issue and maybe the code is just the logic doesn't seem to be working somehow. I'll go back and refresh everything. All right. Other things you can do is you can change the nature of a cell. For instance, I want a heading here. I'm going to say my first for example, right? But if I run this right now, this cell is treated as Python code. I want it instead to be almost like writing, right? So I want to make it into a notebook, like text. So what I can do is I can go to cell, go to cell type, and change from code to markdown. So you can see the color changed a little bit. And by doing that now, I can run this. And now it's no longer code. This is not part of the code. It's just like as if it were a notebook and I'm writing on it. Okay, and that's where the name comes from. So that's the idea with Jupyter Notebooks, is that you create these things that have code, but also results and also text. You can write down your equations. You can have images, whatever you want. So at the end of the day, then it's like a nice little report with everything in there. Okay? So you can do that. And those are the basic commands. If I want to remove a cell, I use these little scissors. And we'll see other things later on, but actually that's basically all I use. Okay? All right, so let's go ahead. Again, let's restart. So now I'm going to load these two libraries, Torch and Numpy. Torch. Sometimes it takes a while. It's thinking. Now there's a number there. This is no longer has that solid black background. So now we can run my first example. We already installed Numpy, but if I needed to install it, I would do that. And then when I'm done, I would comment it out again. I like doing this because then when I also should be honest, it's good practice to do something like this. You want to say Python 3.7, just so I know what version of Python I'm using. If I load this on my GitHub or something like that, and then later on I want to use it, I want to know what what dependencies this code needs to run. All right, so then I run this. I'm going to load NumPy. Okay, it loaded, you can see. So now we're ready for today, right? This is all we need. I'm going to remove this print hello because I don't need it. So I'm going to use the scissors. You can see it's gone. And then I'm going to save and update my file. All right, so we are ready to start working on a few problems. All right, so I'm going to call these tensor operations. Okay, and I'm going to change the cell type markdown. All right, so as I said, so this is not a homework assignment. It's a lot of problems, actually, somewhere between 50 and 70 problems, but they're short. They're meant to be short. And you can just copy and paste them if you think that's all you need. Hey, otherwise, type them up. Okay? And you'll learn a lot about how things work just by typing them up and running them. And they're essentially all the same thing. You're creating objects, data basically. Okay? And you're processing it in some way. It's called machine learning, right? So we have these algorithms, and the algorithms are learning something about data, right? So we're going to have information. We store it in a specific format, and so we want to learn how to process it efficiently. All right, so now let's go back to Brightspace. All right, so these are all like administrative modules. This should be the first module for first couple of weeks. Problem definitions and the ML pipeline. I will do this actually next week, given that it's a short week. So then I'm moving matrices and vectors to today, basically. And this is what we're going to look at. So you can see I have some examples here of problems. And then these are the NumPy examples. So we're going to work through these. So let's open the Word document first. I think it's trying to open it. Okay. Oh, there we go. Yeah, here you can see these are basically like, grab these two and add them together, or grab these two and multiply them times 3 or something like that. So we'll do this towards the end today. But first, we're just going to do a few examples of how we can implement tensor operations in NumPy. So then I have this link. Let me see if this is the right. You know what? I have a new link now. I'm going to change to that. This is my better set. Okay, so I'm going to go here. I'm going to delete that one. To add a new, create a link, tensor operations. So you should have that link now. So let's go back. Let's make sure it works. And we'll just start going through the problems. So here they are, tensor operations. Click on the link, and it should take you basically to my GitHub. So remember, for the whole semester, GitHub is where I usually post my code. You can get it easily from there and see it and have it available. So here I have about 100 or about 70 problems. And you can see they're ordered. So problems 1 to 15, 16 to 30, 31 to 45, and so on. So you can just do these in this order, basically. So today I'll start with problem 1, and we'll just kind of get a feel for how this works. Okay? Does that make sense, guys? So let's just do the first one, right? So we're going to learn how to use Python a little bit, and then we're going to quickly jump into the NumPy library. What is NumPy? Numerical Python, basically. So, if you've ever used something like MATLAB or one of these frameworks, it's basically about taking numbers and sets and kind of doing operations on them, okay? And this is, as I said, is a set of operations from linear algebra mathematics. So what I'm asking you to do, and I'll repeat this again, I'm not making this a homework, right? But I strongly recommend that you go through all these problems, right? And it'll take a long time, but you have a whole semester, right? Make it your goal to go through all of these, do them, and try to understand them basically, at least mechanically. And you don't have to prove them mathematically. I mean, the operations will simply work, right? It's like 2 times 2 is 4, right? So, it's going to work like that. All right, so let's go ahead and grab the first one. So problem 1. And you can see here, problem 1, they're all Jupyter notebooks. So all we have to, and you can see they're pretty short, right? So what I'm going to show you is basically really quickly how we can start to create sets of data that we can use to build our machine learning algorithms. We're going to have a lot of data, basically files that are really large and contain a lot of information. But as long as they have specific formats and things like that, we'll be able to operate them efficiently. All right, so let's do the first example. So I'm going to copy some libraries, and we may not have all these libraries. All right, so here we go. And that's really what we're going to do today. That's essentially what we're doing today. Okay, so here I have Numpy, which I had already added. You can add it again. Torch, I know we have, but we may not have this library, matplotlib. Matplotlib is a really nice library for visualization, and I'll be using that throughout the semester as I need to visualize things, create little graphs and charts and things like that. All right, so let's go ahead and run it and let's see what happens. So I expected that matplotlib is not available, so what do we do then? We can go to this cell where I'm keeping all the things I'm installing, and I'm going to do pip install matplotlib. Hit run and install it. That's it. That's how it works. If you need small agents from Python for some tasks that you're doing and it's not available, pip install. Okay. All right. So here it is. Successfully installed, it says. So now I'm going to just comment this out. I'm going to leave it there, and I'm going to hit run again. Okay, now we can go down here, hit run, and as you can see, it's thinking. So it finished and no errors. So that means that we have successfully imported these libraries. Okay? All right, so now let's do our first example over here. All right, so actually, I'm going to come down here. All right, all right, so if I just do this, just that, without the parentheses, that is basically a data structure in Python called a list, okay? That's what that is. It's an object called a list in Python. See, it's got that format. It looks like that. It's Python. But you don't want to do machine learning operations like tensor operations in pure Python sometimes because you want to be efficient, fast, or you want to employ linear algebra based operations, tensor operations. So what do we have to do? We have to convert that data from the Python list format to a NumPy array format. Once we do that, it's a different data structure that is linked to different efficient algorithms, which will allow us to process this more effectively. Do you guys see that? And that's going to happen a lot. So we'll have data in a text file. Maybe we'll load it in Python as a dictionary or as a list, but then we're going to convert it to NumPy. We're going to do some operations. And then if we're using advanced deep learning algorithms, we'll convert from NumPy to PyTorch, do the things. When we're done, we'll get PyTorch tensors, but we want to do other operations. So we'll go back to NumPy and so on. Do you see that? And that's actually very straightforward to do nowadays. It used to be way harder, but now it's very easy. One advantage of this is like NumPy was first, and it's almost like PyTorch or TensorFlow have copied NumPy, in terms of, so the words are the same, the function names are the same. So it's the same ideas. All right, so now what I'm going to do is I'm going to take this list, and if you notice, I'm going to invoke NumPy NP. So I create an import NumPy as NP, and I'm going to say that I want to convert this Python list into a Numpy array by running it through this np.array function. Got it? And so now A should be a Numpy array, so we can go ahead and print it and see what happens. And if you notice, although the difference is subtle, there is a difference, right? So here you have commas, and that kind of indicates that's a list, whereas here the commas have gone away. The data is still the same. It's just the data structure or the format is different. And now it is a Numpy array, which basically means that it's now you can perform operations on this that are efficient, basically. The key concept that there's really like just a couple of concepts that you need to understand from the mathematics of linear algebra, and one is going to be this idea of the matrix multiplication. All right, so instead of performing multiplications as we know them, we're going to perform a matrix multiplication that has a specific way in which it has to be done, right, for it to work. But what's the advantage of that is that if you use that, you're efficiently processing the data. It's going to be much, much faster, if that makes sense. So that's the key trick, okay? And the operation just works. It's been proven mathematically and has been used for many, many years. Okay, so we will look at that. So that operation is going to be like fundamental. All right, so now we've done problem one. Any questions? Pretty easy, right? And so this is exactly what I'm asking you to do. For all these problems, just do them. Go through them, kind of mechanically learn how it works. It'll really help you to develop a feel for machine learning. And then later on, as we start building algorithms, we'll start using these concepts of Numpy arrays, torch tensors, etc. All right. All right, let's do the next problem. Yeah, go ahead. Yep. Matplot? Yep. Just remove the pound sign, and then you run it like that. So it's exclamation pip install and the library. And then when you're done, just comment it out again. Got it? All right. So let's do another example. So I'm just going to, as you can see, let's do problem 2. Make that markdown, run it. All right, so let's do the next one. So again, I'm just going to go, remember, I added in my table of contents in the module matrices, vectors, and NumPy, I added this link. So we'll need to understand and discuss over time what exactly is a vector, what exactly is a matrix. But for now, just think of it this way. So one good way, actually, because you guys know programming, is you know how to create a variable, correct? And you know how to create an array. You've learned that, right? You can create an array of size 10 and you put 10 values in it. Well, that's a vector. So then what's a matrix? A two-dimensional array, which you also learn how to do already in your programming courses, rows and columns. Do you see that? That's it. So the data is just represented like that. And then we just know that we can perform operations like we can take a matrix that is, 10 by 5 and multiply it by a vector that is 1 by 5. And it turns out that's really efficient in machine learning. And that's one of the key concepts that hopefully by the end of the semester will be very clear to you. And that's like the whole magic of like neural networks, that one fundamental operation. It's so fundamental that they created a processor just for that. Do you know what that processor is called on your computer? The GPU. Like the GPU literally just does that. And your CPU does a lot of other things, right? But the GPU, which is the graphics processing unit, only performs that operation efficiently, really quickly. And so hopefully as we go through the semester, that's going to start to click why that's really important. All right? All right. So anyway, this is fundamental. So yeah, so let's go back then, as I said. tensor operations, go to our little link, go back to problems 1 through 15, which is what we're working through today. And do I have problem 2 here? Oh yeah, here it is. So problem 2. So I sometimes skip problems because they're just for the student to solve, but some of these we can do. So again, the libraries for now, one thing that persists is that these libraries are already in memory, but I guess just for completion, I'm adding them again. You usually would just add the libraries at the top and then have them available. Same libraries, NumPy, Matplotlib, Torch, right? I will do some examples of Torch operations here if I have time, even though we're not going to get to Torch until like week 7, week 8 of the semester. Okay. The first few weeks of the semester are going to be mainly NumPy and learning the algorithms via NumPy. All right, so I'm going to run this one. Just do another example real quick. Okay, so this is problem 2. All right, so let's see. This one, what am I doing? Same thing, but I'm creating now a list and I'm typecasting it to be float. So if you notice, Control copy, Control V, you can see 1, 2, 3, 5. That's the list in Python, and I want to convert it to a NumPy array, but I'm also saying that I want the data type to be float 32. So if you've taken Python, you probably learned that you didn't have to declare data types, but as we go back to being efficient, we probably have to start thinking about data types. So float 32 versus float 64, right? So that's an important issue actually, because if you develop a model that is all in float 64, it's bigger. And that's going to be problematic. So float 32 is just right. You can make models also that are float 16 or less, and they have less precision, but they may run faster. All right, so let's go ahead and run this one and print it. And you can see 1, 3, 2, 5. Essentially, we have our little array, and it is in float type. All right, next problem. Let's take a look. Let's see if I need to do problem 3. I think you get the idea now, right? So hopefully you're following along. So I'll skip some of these, obviously, if they're repetitive. But no, this one is important. So here, I'm going to create a matrix, which a matrix is a 2-dimensional array. So it's made up of several vectors, several rows. So I'm going to go ahead and copy this. I'm not going to add the libraries anymore. Okay, and I'm going to add this in here. So what am I doing here? So this is a list of lists, is what I'm calling it. Basically, in Python, you can create a list that contains variables, or you can create a list that contains, guess what, other lists, right? So this is one way of creating data, but we're going to learn later on that we can create data randomly, or that we will be reading our data from text files or something like that. So here I have a list of lists, and all I'm going to do is I'm going to run it through this nparray function and convert it into a NumPy array. Okay, so let me do that. You can see now this is an actual NumPy array. So there's a lot of things that I can do with this, and this is what we're going to learn. We're going to learn how to index, slice. We're going to learn how to get the shapes out of here. All these things that are going to become very useful operations later on. So for instance, B, I want to know the shape of it. There it is. It tells me that it's 3 by 3, right? 3 rows and 3 columns. You guys see that? And, we're going to learn other things that we can do with this. But that's essentially our example. Questions so far? It's pretty easy, right? All right, so let's look at the next example, problem 4. Let's see if it's different enough to do it. 4. All right, this is a good one. This is a good one. So sometimes we just need to create vectors or matrices that are empty because the values inside have to be learned. Remember, that is machine learning. So the algorithms are going to learn the values that go there and that would be useful, essentially. Okay. So I'm going to copy this and we're going to talk about it a little bit. So I'm going to create problem 4. I think it was 4. I'll type markdown, run it. I'm going to add a few more cells to this Jupyter. Okay, just pause. All right, so let's go ahead and, right. So here, what am I doing? So NumPy and PyTorch have these functions that allow you to say, okay, I want to create a vector, a matrix of this size containing this data. All right, so the simplest case is just to create a matrix or a vector of zeros, basically, right? And then later on, we would learn it. So you can see here, I'm saying I want a NumPy array of zeros that has 10 values in it, and the data type, by the way, is integer. So I'm going to go ahead and run that. And there you go. There's my vector of zeros. Questions? We can try other things like see that? That matrix is big enough to hold image data, for instance. You see that I can take images and that would be 28 by 28. I would spaghettify that into a vector of 784, and that can hold data from an image. And then how many images would I have here? 100. You see that? So I can print the shape here. B dot shape. And it says that it's 100 by 784. This is going to become crucial for us to understand as we move forward. We're going to store our data in these things, these matrices that are 2-dimensional or 3-dimensional or n-dimensional. And when a matrix becomes bigger than than higher dimensions, we're going to call it a tensor. And that's where that word that I've been using, tensor, comes from. Okay, so vector, matrix, tensor. That's going up in dimensions. Because we can store lots of data, right? So just to give you an analogy, here I could store black and white images, 100 black and white images. But what if I have color images? How do those work? So color images have to have, whereas a black and white image has one grid, right? 28 by 28, a color image has to have 3 of that. RGB for the red, the blue, and the green. And then you mix those colors to create color. So essentially an image that is 28 by 28 in black and white in color is 28 by 28 by 3. So that means that this, a black and white image, is 28 by 28 by 1. You guys see that? And so I went from a 2-dimensional matrix that is 100 by 784 by 1, which we can ignore because there's only 1. If I want color, 100 by 784 by 3. What if I have video? You see that? So now, what is video? Video is essentially a whole bunch, 24 frames per second at least, right? So then you would need to have that additional dimension so that you can store all the frames that make up a video clip. Do you see that? And so that's why this is really useful, because it allows you to represent data like that very efficiently. Make sense? So we'll look at this later on, but I'm just explaining to you why this is important. Otherwise, if you don't know about this, try to represent that data in memory somehow. Try to write a few for loops, see how you like. doing that, right? It's going to be very challenging. So this is just super efficient. If you master these things, you can take a whole video and load it in memory in seconds, right? If you have this understanding of how it works. Got it? All right, so we'll look at it again. As I said, I'm just introducing these topics right now, but we will do examples of all of this as the semester progresses. All right, so we did one example there, so let's do another one. So problem 5, let's see if problem 5 merits running it or if it's just very similar. So problem 5. Yeah, so this is similar to what I just did, so I'm just going to quickly copy it. Basically, here I did kind of this already. What's different here is instead of zeros, I'm using np.ones, 4 by 6, and the data type is now float. So if you run it, you can see that basically it's all ones inside. It's 4 by 6, and the content is all ones. Zeros, ones, whatever it is. Sometimes you will need things like this, like in the case of something called a mask, which allows you to kind of have zeros and ones. And basically the ones mean, okay, I want you to use these values where you have a 1, and where you have a 0, don't use those values. So these are tricks that you will learn to process things efficiently, because you want to have if statements in your data of what to use and what not to use, but at the same time, you want to be fast. And so how do you do that? You do that in the GPU by making some kind of operation. So again, we'll see that later. All right, let's look at problem 6. 6. Similar. Now we can just specify a constant value. So in this case, 42. So you can see this is a tensor or a matrix in Numpy that is 3 by 3 with the value 42 in it. And you can see. Okay, that's it. All right. Yeah, good. You can try to set a float and it'll just put a decimal column. I think it marked it as integer initially. You can either do this or convert it, like typecast it, if this doesn't work. Yeah, so this is one thing I really like, especially for you guys nowadays. So you have to think that these things, they started developing them, and over the years, they've made them better. So people started asking questions like the one you asked. Maybe 5 years ago, it wouldn't have worked. But now it does work because they're trying to make it intuitive. All right. So we did the 42 here. If you notice, I did something else. I created a tensor that is like this. Visualizing it, not so easy anymore. You see that? This is not so straightforward to visualize it. But what you have to do is you have to learn how to interpret this in other ways. So it's like if you see, so something that has to happen in machine learning sometimes is maybe it's you see this, or you only see a shadow of this. Do you know what I mean by that? So instead of looking at this, you shine a light and what you see is the shadow of it, but the shadow tells you that it kind of looks like a monitor. So we have to do that sometimes in machine learning because we can't visualize everything, right? Tensors that have multiple dimensions, we just can't see them. But we have to learn how to interpret the data by looking at shadows of them. And so that, for example, b.shape tells me a lot. I can tell what type of a tensor it is. It's like a cube kind of a thing, but it's not so easy to visualize unless we were looking at it in 3 dimensions. And what if it's 4 or 5 or 1,000 dimensions, right? How are we going to visualize that? It's impossible. But some of the operations still hold, even for higher dimensional objects. So that's the vector space model, by the way. So I'll talk a lot about this. And that's one of the key representations of things in machine learning. Okay, so we will discuss this quite a bit during the semester. KNN is the first algorithm where we're going to try to think about that. But just be aware. We can't always visualize things, but by printing the shapes, we have an intuition, a shadow of what it looks like. Okay? Any questions? Shapes are really important also. It's one of the critical things in building like neural networks, etc., because you're gonna, let's say you give a neural network something that is 2 by 3 by 3, it's gonna go through some layers and then produce something else that may be in other dimension. And so the next layer needs to take that as input. So it needs to know that set of dimensions. Do you see what I'm saying? And so understanding that is really important. Like understanding the shapes, they need to be compatible for it to work. Okay, so that's one key thing. So this is really nice. Shapes are something that we will use a lot and you'll learn to really appreciate it. All right, so we did that. Let's go to problem 7. Okay. Let's see this one. So this one, A range. Let's do this one. So this is another way of creating data. So I really like actually just creating data randomly and in examples. So because I don't have to go through all the trouble of downloading a file and processing. So here we have a range. And what I'm doing here is I'm creating a range of values from 1 to 30 with step size 3. Right? And so that's yet another way of creating data. So maybe you're doing this. Notice there's a sequence here, right? Happening. You're going from a lower number to a higher number. So that may be useful sometimes in some circumstances. Okay? So you'll see later on that we'll find use cases for just about everything. Okay? But right now I've actually put together this set of problems, which I think are like the most critical for a lot of the problems in deep learning. Okay, so that's kind of the idea, is what I have found to be the useful common operations that you might need to understand in deep learning. All right, so let's do problem 8. All right, and you can see these are very easy. Obviously, as we move through, they're going to become a little bit harder. Okay, so the first 30 or so are very easy, but there are some that are a bit longer, more involved, have more steps. This is another one. Notice these values are now floats, right? So fractions. So we can go over here and run another set of problems. Here, instead of a range, we're using from Numpy linear space from 0 to 1. And instead, what we want is we want 20 values. So it's going to pick the step size for us. And you can see that it increments basically by 0.05 or so. And it gives you that list. Got it? It's another way of creating data. None of this data is random right now. Instead, all of this data follows like a specific pattern. Okay? Linear space. Yep. And then you can specify the parameters that you want in here to create data that looks like this, which again has the pattern of increasing, has a specific step size, and so on. Again, why do you use this? We'll find a use case for it later on. All right. Let's do another one. So that was problem 8, I think. Yeah, let's do problem 9. What's this one? Random data. So this is nice. So random data is great. Random data, you need sometimes just to initialize. You're going to learn something. You need to learn a matrix of values, and you have to have some numbers in there. So you could have zeros, you could have ones, or you could have random values. And it turns out that sometimes having random values may be better than having a bunch of zeros, especially if the model is starting at that specific number and it's going to learn from that. If everything is the same, it may be worse than if you have multiple points where you're starting from, because that can lead you somewhere. It's like here, right? I want to find something, but we're always starting from over there, right? Versus starting from everywhere, and then maybe we have different directions, different paths that we can use to find what we're looking for. Do you see what I'm saying? So it's kind of like that analogy. when you're searching for something. So that's something that we might do later on. And so we want to know how to initialize things randomly. So here I have np random.random. The word random means that we're creating things randomly. And I want a matrix that is 4 by 4. And there you go, random values. I can even create random values that follow specific distributions, like from statistics. When you took your statistics course, or if you'll take your statistics course, you probably learn about normal distributions, right? The Gaussian mean and standard deviation. That tells you that the mean is 10 with a standard deviation of 1. So all the values are going to follow that for some reason. All right. So we'll talk, all of these concepts are pretty important, but for now, we're just learning about tensors, shapes, and initialization. Any questions, guys, so far? All right, great. So let's do, so that was problem 9, I think. Let's do problem 10. 10. Ah, this is a random normal distribution. So a little bit different. So as you can see, here we want a mean of 0 and a standard deviation of 1. So basically our numbers are going to be, and it's a matrix of 4 by 4, right? So 0 and deviation of 1. So our values are going to be somewhere between like -1 and +1, because they're going to be in the mean 0 and then, you know, towards the negative side or the positive side. Again, that's really useful. All right. Problem 11. Here's another, so let's look at a few operations here that are a little bit more advanced, the same libraries. Let's start with this. Okay, so here, this is called the identity matrix. All right, this is a type of matrix that you will use sometimes in some matrix multiplications when you want to achieve a specific goal. All right, so we'll see that later, but you can see numpy.I, dimension 5. It's a square matrix, so you only need to specify one of the dimensions. And you can see that there. Basically, it's going to be 5 by 5. And how would you describe this matrix, basically? All the values in the diagonal are 1, and everything else is a 0. And this is a useful matrix that we can use. This is one concept from linear algebra, one of the few that are like linear algebra concepts that are useful in the things that we do. Okay, and so we'll see later on things like this. It's basically for selecting things. This is actually a matrix, and when you have a set of values, it allows you to select certain things and exclude other things. So it's convenient. All right, we had some additional things here. So let's see, let's do this. Now, so I have 1, 2, 3, 4, 5, 6, a list of lists, and I'm converting it to a NumPy array or a matrix. I'm also going to print the shapes and dot shape. So this is 2 by 3, but as it turns out, there are ways that, imagine this is a 2 by 3 matrix, right? And sometimes what we may want to do is to do an operation, we want to like rotate that matrix kind of like that. Do you see that? So that's one of the operations that we might need later on. All right. And so there's a command for that, which is called a transpose. Well, I'm going to do that. All right. So you can see I'm taking the original n and I'm going to transpose it and create P TRA. Hit run. You can see it now 1, 2, 3, 4, 5, 6. And that's how it works. Like literally, it's almost like an algorithmic approach. You have rows and now they become columns in this order. Okay. And so you can also print the shape. So P TRA dot shape. And you can see it is now, instead of 2 by 3, it is 3 by 2. So this is one of those things, pay attention to it. Okay, it is a concept from linear algebra. Repeat it multiple times, have it in your like cheat sheet, because there will be some algorithms later on where I'll just say, okay, we're going to do the transpose of this, and this is how we make it work. And I want you to understand where it's coming. Got it? So that's why I've created this beforehand, because otherwise, when we look at the algorithm, you're going to be like, what's transpose exactly? Does that make sense, guys? All right, and that's so that, again, that operation called a matrix multiplication, which is, by the way, what GPUs do exclusively, can be done correctly. All right, and the challenge a lot of the time is really getting those shapes aligned. So that's why you're always going to want to print the values. Like when you're doing the operations, you'll print the shapes, try it out. It's going to give us an error. And then eventually, intuitively, you'll figure out how to get things to align just right for the operation. Okay? This, as I said, this is one of those very few concepts that do come from linear algebra. All right, and we did that one. So this was problem 11. Let's do problem 12. Oops. I'm going to add, keep track a little bit. Problem 12. So we've done a lot, right? So there's about 80 problems that I'm asking you to do in this repo, and we're about 12 right now. So no, don't. Type mark down. All right, problem 12. I'm going to save this also. Okay, problems 1 through 5. Let's take a look at problem 12. Right, so this is, a little bit more involved. And this starts to get into printing out things like data types, size, shape, number of dimensions. Again, this hint of your data, first of all, is going to be so big that there's no way that you can just print it and look at it, right? So instead, going back to that analogy, we have to shine a light on it and just look at the shadow of it and kind of infer from there. So that's what this is. So I'm going to here create a couple of NumPy arrays, and I'm just going to print some of the values that we need, okay? So let's add in here. I'm creating B1, B2, B3. I'm using NumPy random, and I want random ints in there. Dimension is 20, and I'm specifying multiple sizes arbitrarily, really. And then I just want to print values, right? I want to print information about them. So let me move this down. All right, so let's do this. We print B2 and B3, but as you can see, it's kind of hard to interpret this. And these are very tiny. Real data is going to be massive. So we would not be able to make any sense of this. Now you might say, okay, but you already have the values there. Why do you need to print them again? You're right for this case. But when we're starting to do machine learning problems, we're going to be reading data from text files, from folders. We might have 100,000 images, right? That we have to color images that we have to load into memory. We don't exactly know the shapes of that. We know how to load it. And once we load it into a tensor, we have to print the shapes to start to understand what we have. Got it? Makes sense? All right, so we've got this now, and now we're just going to start printing the value. So I'm going to run this. So B2, this one, it's 3 by 4. So the number of dimensions, and dim is the number of dimensions. It's got 2 dimensions, rows and columns. B3, we want the shape of it. So here it tells us not that it has 3 dimensions, but the actual shape of it, 2 by 4 by 6. Got it? So it's a cube, right? So imagine like a Rubik's Cube type of a thing, right? And you can picture it that way. The next one, the size of B2 is counting the number of cells in it. 3 times 4 is 12. So it gives us 12. You see that? So all the values. And then the last one for B3, we created arrays that are int. So it's giving us the data type, which is int 32. Okay. Any questions? All right. Yeah. So yeah, please go ahead.
Oh, I'm sorry. I just can I see that last sum?
Yeah.
Thank you.
Like the print statement.
Yeah, I just want to write this out.
And you can get it from the GitHub. So
Oh, okay. Thank you.
right. So I'll remind you guys the task, right? So this is not a homework assignment, but I think it is to your benefit to go through all these problems, spend a weekend or however you want to do it. And actually, I would recommend just once you finish, start all over again, right? If you have time, because it really will pay off later. Yeah.
They'll just like plot, right? Like we don't have to do anything, we'll just copy paste it and then.
But understand what's happening.
Yeah.
Yeah. And if you don't, ask me for sure. Well, I mean, they're just like what I've been doing, right? So that's why I'm doing this. So you copy, paste it in, hit run, and it should give you some results. And you should try to understand what's going on. But like I said, if there's any problems that you don't understand, ask me. Later on in the semester, as we start going into the different algorithms, I'll say, oh, remember problem 37? Remember problem 45? You see what I'm saying? So all of this came from all the problems that I have. I just like summarized it into little operations. So what I was saying to him, that you should do this. You don't have to submit it, but definitely practice. Here's the link.
Oh, thank you.
So here's the link on Brightspace. You go to module, matrices, vectors, and NumPy. Click on tensor operations, and it's all these problems here in these folders. So we're currently on problems 1 to 15. Okay? All right, so what was that last problem? That was 12. So I think we finished it. So let's do problem 13. And let's see if that one is worth doing. 13 here, right? 13. What's this one? Indexing. Oh, that's a nice concept, right? So we start to, so what's going to happen is sometimes, for instance, we're going to read in the data. But associated with that data is we're also going to read like something called a label. So let's say that we have images, right, of cats and dogs, but we load all the images into one of these arrays, right? And every row is an image. Then associated with that row of images, we want to have another column that says, by the way, this is a picture of a cat. This is a picture of a cat. So we're going to designate that by simply putting in like a 1. And then cat. When we have a dog, what do we do? Instead of a 1, we can do 0 or -1, just a different number. Do you see what I'm saying? So sometimes then, when you read your data from a file, you're going to read both the data of the image and also the label. But then you need to like separate those out, right? You're going to need the column for the labels in a vector and the data of the images in a matrix. So we need to, and that's called, we use operations like indexing, or we also use another operation called slicing that we need to learn about. And slicing, like when you slice a cake, right? So how do you do that? So this is indexing, which you guys know indexing already. Basically grabbing an element from an array or a matrix or something. So let's go ahead and do that one. So I'm going to write in here indexing. Okay, cell type, markdown, run. Okay, so I'm going to create first. What is this? This is a big this is a list 1 3 2 5 float 32. Okay, so it's pretty easy. Let's print it here. Okay. All right, so we have our list there, a NumPy array in this case, 1 3 2 5. So I'm going to add a few cells, break this down. So the first one all I want to do is I want to print the first element. So remember, these things start with 0 in indexing and programming. So we should grab the value 1. You see that? We got the first one. How do we do that? We got A, and then we provide the index 0. This is the third one, so I can skip that one. This one is pretty important. So let's do that one. -1. So -1 is basically looking on the indices in reverse, right? Instead of from beginning to end, we look at them from end to beginning. So we grab the last one. And in general, in machine learning and these libraries, the -1 usually indicates the last element. And that's going to become useful too for several reasons. So the last element is 5. Do you see that? If we do and then we can do these last two. So that out. And you can see -2 gives us this one. Got it? All right. So this is another thing that when I'm doing algorithms, you'll see me throw a -1 in there. So hopefully it'll be fresh in your head what it means. Okay. All right. Next problem. So that was problem 13. Let's do 14. All right, so what is this? This is still indexing, but with a matrix. Okay, let's go ahead and do that. So indexing NP array, this is a 3x4 matrix. We can print it, then we grab index 0, 0, or we grab 2 minus 1. All right. So one thing tells us what row it is, and then once we've grabbed that row, we want to grab an element from that row, right? And so the column, basically. So let's go ahead and, let's go ahead and run it. So the first element, 0, 0, 0 is the first element, so that should be 1. Do you all agree? And then the other element is 12, the last one. Why? Because since it starts at 0, so it's going to be 0, 1, 2, and then the last one, 12. Does that make sense? All right. Now, this is an exam type problem. I ask you to write the code to index the number 7 out of it. How do you do it? I want 7. So change this code here to get me a 7. Oh, sorry. Yep. Good. There you go. You see that? That's what you have to become really good at. Okay, that's why I was saying for this kind of thing, maybe you need to practice these problems a little bit more. All right, so that's indexing. Then we have slicing. So slicing, so here, if you notice, we're just getting one value. But sometimes we may want to have several values. For instance, what if I want the column 4, 8, 12? Like I want that sliced out. Or maybe I want the column 3, 7, 11. Slice it out. And we're going to use it as a separate thing. Do you see that? So that's one of the where we're heading now. So we've done problem 14. Let's take a look at problem 15. This is, I think this, this is slicing actually. So let's take a look. We'll start with something easier. So this is slicing. All right. This example, let's move it up. Okay. So slicing, right? So what I just said, like slicing a cake and segments, we use a range, 15 values, we print it out. There they are. Now I want to slice The first the first four elements. So how do I do it? So here we're going to learn a couple of new things. One of the things we're going to learn is this symbol. Oops, not that. This symbol, the colon. So the colon in NumPy and PyTorch is used to indicate ranges. Do you know what I mean? Like from 3 to 7 or something and something. So it indicates ranges. If you provide a value here, then it basically says until that value. If you leave it like that, then it just says from beginning to end. You see that? So for instance, in this case, it was 4. And since we are leaving this blank, we're saying from beginning until that index, 4. You guys see that? So let's do these individually. Keep it easier to grasp. And let me add cells here. Okay. And let me save. So I'm going to run, and you can see it just it slices out another NumPy array, but just of what I requested. Okay. Let's do another one. Once again, we look at this array of values. Now I'm going to slice all after 3, the 3 index, right? So remember, we're not going by number. We're going by index position. So this should be from like 3 or 4 all the way to 14. Yeah, from 3 all the way to 14. Do you guys see that? Colon, and this indicates until the end. All right. This is another exam type question that I may give you, and you just have to write that simple piece of code. What if I want even indices? So here we have like our basic approach from beginning to end, and then we add a second colon to indicate step size. Right? So in this case, then it gives us 0, 2, 4, 6, 8, 10, 12, 14. All the even indices. What if we want uneven indices? What do we do? This same thing, but just start shifted by 1. And now it's going to give you all the uneven. So you can see the 1 there. Oops. 1, 3, 5, 7, 9, 11, 13. See that? So what does this illustrate beyond the operation of slicing? It illustrates that sometimes you have to be clever in your machine learning in order to be efficient. It's not about the cleverness. The cleverness it's about the fact that if you do it in another way, your machine learning training would be slower. And at the end of the day, when the data becomes massive and everything, you really have to be really fast and efficient. Okay? So little tricks like this help. And so you'll see, and it's not that you have to come up with these for an algorithm. They will be in the algorithm already, but you want to understand why it's in there, So that's kind of the intuition. All right, so we did this one. Ready. And then let's take a look at this one. Let's see what happens. So this one's pretty interesting. So this one, the same, but the step is -1. So basically the value is negative. It starts at the last element. So it kind of reversed it, if you notice. 14, 13, 12, 10, and so on. Little nice tricks. Yeah, go ahead. So this is the step size, not the. Actually, that's a good. Yeah, let's run it. That's the beauty of it, right? So 14, 12. Yeah, so it actually did 2 things, right? it reversed it, and also the step size. So there you go. It's very powerful. This stuff is powerful, and as I think you proved, intuitive. You kind of, one thing, if you don't know, just run it. And then run it with a simple example. I mean, I don't think I've ever been asked that question. So, and think through your problem. Good. Any other questions? So you guys get the gist of this, right? And I've only done 15. There's I know the range goes all the way, it says it goes all the way to, I think, 120, but there's some missing problems that are not here. So in this one, like 106 to 120, you can see there's actually only 3. I haven't included the other ones. So you don't have to worry about it. Just do these ones, and as I said, you don't have to submit this as homework. It's basically just for you to develop, the skills that you're going to need in this class. Practice Numpy, to practice torch tensors. Actually, let's do that. We have a few minutes left, like 15 minutes or so. So I've shown a lot of examples of Numpy. Now I'm going to start with PyTorch examples, and they're very similar. We just have to use a different library. But I leave the rest to you to go through and practice these. So let me find, so 16 through 30. I don't remember actually where PyTorch starts. Oh, this is still NumPy. Yeah, and some of these are matrix multiplications, etc. I did 30 there, so 31 to 45. Let's see, like 41. Torch, there we go. So these are torch examples. So let's try some of these. Let's start at 34 maybe. Yeah, I think actually it starts here. So here, instead of NumPy, I'm going to use torch, which is also called PyTorch. So I'm going to do Markdown. All right, hit run. All right, so basically very similar. Let me move this down. Here I'm going to, just like NumPy had a function called ones, Torch has a function called ones, right? So torch.ones, size 5. Hit run, and you can see the data is the same, right? So that hasn't changed at all. But what has changed is what? The data structure that's holding things. So if you're doing something that requires a NumPy array and you give it a torch array, it's not going to work. That's a very strict rule because that's the coding, basically, the coding part underneath. So then you have to convert your torch to NumPy or NumPy to torch if that's what's required. The data stays the same, but the data structure changes. So I printed the tensor. So we can change the value here. For instance, we can typecast it, but I'll skip that. I'm just going to do this. So here I want to change one of the values of this torch tensor to 1456. And we want to print it again. And there we go. And it's in scientific notation. That's why it shows it like that. There's a setting to change it to normal. I don't remember off the top of my head. Got it, guys? So as you can see, almost exactly the same thing. All right, so that's one really nice feature. So we did that one. Let's do a couple more. Let's look at them. So that was, I want to keep track of this, problem 34. So let's look at 35. Okay, so this is argmax. This is a very useful function. We will use it a lot. So what happens is when you're predicting classes, let's say that you're predicting cat, dog, or bird, right? What machine learning does is it knows that the first one is for cat, the second one is for dog, the third one is for bird. So what the machine learning algorithm will do sometimes is it predicts like a probability, right? So it's saying, I think it is the second one, dog, with 70% confidence. You see that? And so you're going to end up with something. So let me do that. Let me copy this code here. You're going to end up with something that is like, so I'm using 3. So let's say 0.10, comma, 0.70, comma, 0.2, right? So basically cat, dog, bird. What the machine learning algorithm produces is just like a probability distribution. It learns how to say, I think I look at this image and I think it's more likely with 70% accuracy that it's the second one, a dog. Okay. So once you have that, what you'd really need is you don't want 0.70, right? What you want to know is which class was selected. Was it the first one, the second one, or the third one? So that's what argmax might do. So there's another one called max. So let's print answer 1. And it says the tensor is 1. Do you see that? So let's make this one 0.7 and this one 0.1, 0. Let's make this one 0.7 and this one 0.2. What should it be? So, do you see that? So that's why this is useful. So argmax, it seems like out of context here, but as we use machine learning algorithms for classification, you'll see why we need to use something like this. Okay? Yeah? Making sense? So yeah, so these are the operations that you have to do. Let's take a look at another one. We have a few minutes left. So we did 35. Let's do 36. This might seem alien to you, but it's actually really useful. So, oops. So I'm going to create a tensor. Whoops. There we go. This is a tensor that is 64 by 1 by 28 by 28. A Rubik's Cube would have 3 dimensions. This one has a 4th dimension, 4 dimensions. Humans cannot. There isn't a human on Earth that can picture something that is 4 dimensions. We have no concept to visualize, but we can up to 3. However, by looking at this, we know what it is, and there's some math operations that we can use, some tensor operations. So what does this represent? This represents 64 black and white images. If I had color images, I would need a structure like this. So that why 3? So I can hold 3 28 by 28 grids. One for the R, one for the G, one for the B, which we know if we combine our red, green, and blue, we get all colors. Okay? So this one is required for our machine learning algorithm to work. But if it's only 1, we really don't need this to be a four-dimensional matrix or a four-dimensional tensor because it's just that one dimension. So maybe an operation, a math operation needs to happen that needs that one, but we may not need to have it really to represent data. So we can get rid of it to make this into a 64 by 28 by 28. So we will have situations where we need to perform operations like that. So we have these funny named functions called squeeze and unsqueeze. As you're squeezing it or unsqueezing it to release dimensions, basically, or restrict dimensions. So here I'm taking, notice, torch.squeeze, and I take in as input batch dummy torch. And I specify which dimension I want to squeeze out. Now make sure it's logical what you're doing also. In this case, it is. That's the thing we want to get rid of, the one. And then we print the shape. And now it is a 64 by 28 by 28. If we wanted to add that dimension for whatever reason, maybe for some operation, there's something called broadcasting, which is an additional concept that if you really go into machine learning and things like that, you want to master. And because it makes your more efficient. So if you needed that dimension in there for broadcasting purposes, then you would, instead of using squeeze, you would do unsqueeze, the opposite of it. And you specify where you want to put that one, and it takes your Rubik's Cube and makes it into a four-dimensional Rubik's Cube. Do you guys understand that? Is it making sense? As I said, we're going to see all these operations within the context of the problem as we move forward. All right, so we did that one. We have about 6 minutes left. Reshape is another useful one, so let's take this one. So we'll do this a lot. So I call this spaghettify. Like if you ever heard of well, I mean, if you imagine if this was cloth, right, like knitted, right? So it's a thread, and I had a string here and another string here, and I grabbed both of these and did this, I could end up with just one thread, right? Instead of having this fabric. So that's a similar idea to having a two-dimensional array that I convert into a vector. I spaghettify, right? Or I can reshape it. So in this case, I have a cube that is 64 by 28 by 28. I want to take the images, which are 28 by 28, and spaghettify them without losing any information. So that means that I would convert the 28 by 28 matrix into a vector of what dimension? 28 by 28 is what? 784. Okay? That's actually one of the most important references that you can try to memorize if you can, because it's connected to the very famous MNIST dataset. And we'll talk about that dataset at some point. And images in MNIST are 28 by 28. Black and white, so you only have one grid. And then a lot of the time when you're processing, you may want to convert it into spaghettify it and convert it into a vector of size 784. So that's what I'm going to do here. So the way that I can do it, since I already know what 28 by 28 is, I can just do this. But I could also do, if I don't know, I could just say 28 times 28, which is the same, right? And here's that -1 again. Here, the -1 may have a slightly different meaning. It doesn't mean the last. Instead, it says when you're reshaping, infer the other dimension. You can only infer one dimension. So what I mean is if I have 64 by 28 by 28, I can't say 64 comma -1 comma -1 because it's not going to know how to infer that. But if I say that I want to reshape this into this, I can say 28 by 28 here, and there's only one dimension left, right? Which is the -1. So it should infer 64. So let's see if it does it. It does. 64 comma 784. What I did is I reshaped a cube, right, into what? Into a matrix, from 3D to 2D. And that's going to be important because when we build neural networks or other architectures, we may not be able to give our machine learning algorithms grids of images, but we can give it vectors of the images, and that's going to work nicely. Got it? Any questions, guys? Making sense? All right, yeah, so we're almost out of time. I will come back to like the matrix multiplication because I think that's sufficiently important. Some of these you can just do on your own. And as we progress, obviously, with the algorithms, you'll see some of these again. But also, I may highlight at least a matrix multiplication, but we'll save that for, because that's a more complex topic. Let's save it for another class, okay? So again, I'll repeat for today, no homework assignment, but I do think I would highly recommend that you go through all these problems, basically do what I did, run them, see what happens, try to understand what's going on, because as we go through algorithms, you'll see them. We'll be using these techniques to make our algorithm, something that might take with for loops 50 lines of code, with something like this will take 10 lines of code. So it makes life a lot easier. All right, I'm going to stop the video recording here. So I'm going to do